All right, it's 5 o'clock our time, exactly 3 UTC. Good morning, good afternoon, or a good evening wherever you are on the planet. Welcome in this new webinar. And this new webinar is all about the Raspberry Pi. So let's get started for this exciting webinar. And actually, we are going to start this webinar with a poll. Just to have a look at what your experience is so far with the Raspberry Pi, what your ideas and plans are with respect to the Raspberry Pi. So I prepared this little poll that I'm going to show you right now, should appear on your screen. And in this poll, we have the questions: have you used the Raspberry Pi before? Yes or no? And do you plan to use the Raspberry Pi in the foreseeable future? So you have some time to check your status with respect to Raspberry Pi. And then we can have a look at the results of our audience. So we have a little bit of feeling of who is here today present for this webinar. So let's close the poll, and it's counting down right now to give you the opportunity to check your answer. And then we are going to have a look at the results of this first question. So, okay, the results are in, and I'm going to share the results right now with you, where we can see that 66%, so 2/3 of you have already used the Raspberry Pi before. So that is a nice 1/3, has plans or has not used it yet. And do you plan to use the Raspberry Pi? Well, 100% indicate yes. So that's good to see that there is a very good interest in using the Raspberry Pi. And I have a second poll for you, and that is in for what goals that you will want to use the Raspberry Pi. So questions is how do you plan to use or are already using the Raspberry Pi? Is this for hobby project, for professional projects, or is this for both hobby and professional projects? So 4 options you can select from. The first option, I think no one will answer, because you all indicated that you have an interest in using the Raspberry Pi. So the poll is on your screen right now, and you can select what fits for your case. I'm starting the poll will close, so it's counting down, giving you a few more seconds to fill in the answer, and then we'll get started with the webinar for today, which is about using Miletus for the Raspberry Pi. So the results are in, and I share the results right now with you. So here I can see that about 20% of you want to use it for hobby projects. About 26% wants to use it for professional projects, and more than half of you, 52%, will want to use it for both professional and hobby projects. So that's very nice to see. And okay, I hope, of course, this webinar will be useful for you in whatever project you are planning to do with the Raspberry Pi. So what do we have in the planning for today? What you will learn? First of all, you will learn what a Miletus app is, because after all, we are talking about a Miletus app that will run on the Raspberry Pi. We will have a brief look at the architecture of the Miletus application, and we will show you how you can create that Miletus application from your Delphi IDE. Next step will be to have a look at how you can deploy the generated application, the Miletus application, to your Raspberry Pi device. We will also have a look at how a Miletus app for Raspberry Pi is different from, let's say, a regular Miletus app, a Miletus app that can also run on a Windows machine, a macOS machine, and a Linux machine. And we will also have a look at what the capabilities are that are built into Miletus for accessing hardware that is connected to your Raspberry Pi. So first of all, what exactly is a Miletus application? Well, a Miletus application that is actually technically a native application that is hosting an embedded browser. It is the application itself, the application that you built for the Miletus application, or for, let's say, the Raspberry Pi in this case, will be an application that is running inside this embedded browser. And there is a bidirectional bridge that allows you to access the operating system from your application that runs in that embedded browser. And at the same time, of course, there will be communication from that native application also with your web application that runs in this embedded browser. And so it is a bidirectional communication between this embedded browser and the native application. And it's the native application that will do all the interaction with the operating system it is running on, in this case, or for today, specifically for the Raspberry Pi. The web application that will run in the embedded browser in your native application is packaged as resources in your native application. And it is designed in such a way that you can run these applications fully offline. So there is no need to have your Raspberry Pi connected to the internet for the sake of running the Miletus application. No, also on a not connected Raspberry Pi, these Miletus apps will run just fine. And so, as you can see here, it's a kind of game between an embedded browser and, in this case, the Delphi IDE. But I have also put here the Lazarus logo, because obviously the native shell application that will run on the Raspberry Pi is built with the free Pascal compiler from the Lazarus IDE. So this is also important to mention, and this also plays a role in creating these kind of capabilities. A deeper look at the Miletus application itself, so the web application that runs inside the embedded browser. It is created by compiling Object Pascal. Some prefer the word transpiling Object Pascal to JavaScript. The UI of this application will be web-based, web technology-based. So typically this is using HTML5 and CSS3 to render the user interface, and you can take advantage of all the capabilities to create nice GUIs using these technologies. As I explained, the web application itself and any resources needed for that application, these will be packaged as resources into the native application. And when your native application starts, it will show the embedded browser, and it will run your web application, your Miletus application, inside this embedded browser. And we offer several classes and components that perform the bridging between your application and the operating system, here in this case, the Raspberry Pi OS. Functions like getting access to files, open and save files on the file system, text files, binary files, and other functionalities we will have a closer look at to access the hardware, for example, on the Raspberry Pi. And the workflow to accomplish this from the Delphi IDE is in the following way. When you have your Delphi IDE running, you can choose to create a new project, and you will find this under File, New Project, and then in the category TMS Web, you will find the entry for an Miletus application. And you select this type of project, and when this project has been created in the IDE, you can select from the tool palette the Miletus specific components, classes, and use these to create your application. From the IDE, you will compile your application, and it will produce, in case you select as an output your Raspberry Pi application, it will produce the executables for running on your Raspberry Pi. And here you can see how from the Delphi IDE in the project manager, you can see how you can select your target. So we have two targets, a release build for the Raspberry Pi and also a debug build. The difference between the two is that when you build for debug mode, you will have an access to the browser console to perform additional debugging in your application running on the Raspberry Pi. When you build in release mode, that option is of course not possible. And you can see here this Miletus application has also a lot of different build configurations. So you can, from the same application, target Windows 32, 64, a Linux desktop application, the Mac OS, Intel-based and ARM-based executables. So this is a set of build configurations that always comes with a Miletus application when you create it in Delphi. Important to note here is that the Miletus application that we create from a Delphi IDE is specifically targeted for the Raspberry Pi OS. So this is a kind of default operating system for the Raspberry Pi. It was named formerly Raspbian, but the Raspberry Pi organization now officially named this Raspberry Pi OS. Yes, there are other operating systems that you can run on the Raspberry Pi hardware, but the executables that we create from the Delphi IDE in Miletus are specifically generated for, let's say, the most popular operating system for the Raspberry Pi being the Raspberry Pi OS. The deployment to your Raspberry Pi is, I think it cannot be simpler than this. It's the simple Xcopy deployment. So you just copy the generated files. There are two files. There's an executable file and there is a .desktop file. And this .desktop file, the purpose of this file is to make it startable, your executable startable from the desktop, from the Raspberry Pi desktop. And this here is a look at the files involved. So the project in the left top side, where you can see the project file, one form file, a couple of icons for your application, and where we show you the output folder. So these are the two files that are generated from the Delphi IDE when you compile for Raspberry Pi. You can see an approximately 7 megabyte Miletus Raspberry Pi executable and a short file, a small file, which is a desktop link file. Now, what makes Miletus app for Raspberry Pi different from a regular Miletus app? As I explained, a Miletus app, you can run that or compile that for Windows, Mac, and Linux. When you compile it for Raspberry Pi or want to use it on Raspberry Pi, there are some differences. One of the differences is that at this moment we have only support for web client dataset. So where in Miletus Windows, Mac, or Linux application, there is support for using local databases like local network databases like MySQL, SQL Server, Firebase, and a few others, Firebird, sorry, and Interbase. This is at this moment not yet available for the Raspberry Pi. You can use web client datasets, meaning that you consume databases over a REST API. That is possible. There is an extra unit that is specifically for the Raspberry Pi, and in this specific unit we have the components that are exclusively to be used on the Raspberry Pi to access the hardware that is available. And we have 3 components for that. There is a component to access connected hardware over I2C, over the SPI ports, or the UART port, and there are also methods to access the Raspberry Pi general purpose IO pins. So whatever sensors or displays that you connect to your hardware to the Raspberry Pi, you can use these components to access that. So here is a look at the I/O capabilities of the Raspberry Pi. The Raspberry Pi 4 in specifics is this. And so as you can see, this has by default 2 I2C ports, 2 serial peripheral interface ports. There are 11 exclusive GPIO pins. There are more, but 11 that are exclusively for the purpose of general purpose input output, and there is a standard 1 UART. And so these are the hardware that you can use also from the Miletus application that you create in the Delphi IDE. And here is a brief look at the class to communicate over I2C with hardware. You can see here that you set the I2C address of the electronics that you connected to the Raspberry Pi. There is an open and a close for communicating, and then you can basically read and write bytes or buffers of bytes, multiple bytes, and set addresses to access registers in I2C devices connected to your Raspberry Pi. There's also a component for accessing the SPI ports, the serial peripheral interface ports, where you set the port number, you perform open and close operations, and you can read and write buffers of bytes to these SPI ports. And the third option is using the UART, so serial communications. You can open and close the serial port, set its properties like baud rate, parity, bit count, stop bit, and then you can read and write also here buffers of bytes to your serial port. Maybe one interesting thing to note already is, as you can see, the read buffer and write buffer methods or functions better. These return a promise. These are asynchronous functions, and as they return a promise, you can perform an await on that promise, meaning that you can write sequentially structured code, but still under the hood, the things will happen asynchronously. And finally, there are 3 methods or functions to deal with the GPIO pins, general purpose IO, basically configuration of a pin. As you know, on the Raspberry Pi, these GPIO pins can be configured to be input pins or output pins. That is the configuration that you can set. And you can perform read and write operations to set the value or to read the value on these GPIO pins. I see a question already. Is the SPI support for an SPI Master or an SPI Slave? At this moment, it is for SPI Master, where you will, from the master, talk to several SPI slaves connected to your Raspberry Pi. So if there are at this moment no more questions, I think it's more than time to turn to our Delphi IDE and have a look at how these things work. Okay, let's switch to the Delphi IDE. And we will generate our first Miletus application. So from new application types, I select here a TMS Web Miletus application, and it generates the application for us. I will save it somewhere on the disk so that we can find the generated files. And let's put this here under the folder webinar, like this. And so let's save the project. I see, meanwhile, a question whether the Miletus apps will work on the Raspberry Pi Zero. We have not tested that ourselves here yet. We have performed all our testing on the Raspberry Pi 4. That's an interesting question and something to be checked out. We generate this application for the Raspberry Pi OS. So if the Raspberry Pi OS runs full-featured on the Raspberry Pi Zero, that should in theory work, but that is something to be verified. That is a good suggestion, and actually something that I will propose here in the team to also play with the Raspberry Pi Zero for those who want a really low-cost solution, small solution. That's indeed an interesting suggestion. So here I have created my first Miletus application, and we will create a classic Delphi application. Probably we have all done numerous times since 1995. And so what I will do is the really basic thing. I will add in the memo what I have typed in my edit control. So one line of code. We'll first have a look, because as you can see in the build configuration, my build is first for a Win32 app in debug mode. So let's first have a look at how that behaves, what the result is. So it's generating our application right now. And this is a first time question. Once you allowed it, that will be done. And so what you expected here is the behavior of this application running as a desktop application, a Windows desktop application. You can see the menu here. That menu is because I'm running in debug mode. That menu will not be available by default when you compile in release mode unless you add your own custom menu. But this is basically the application right now running on a Windows machine. And let's have a look at what has been generated. So this was the folder of my application. And and make it a little bit bigger. Here is our project. This is the output folder. And you can see that right now it has generated this executable. I can run it directly from here as well. And this is the application that we just built on Windows. This is a 10 megabyte application. So now I will convert this or select another build target, and let's choose the debug Raspberry Pi target that is selected right now. And let's build the application now for the Raspberry Pi. And let's see what happens in the output folder. You can see that there is now a new folder, and this folder contains here two files. These are the files to be deployed to our Raspberry Pi. And this is actually what we are going to do now. I will show you how we have set up here the environment. First of all, actually, the Raspberry Pi is in an office that is just next to me. It's not on the desk where I am. It's in an office next to me. And so here you can see the actual Raspberry Pi that we are going to target. Interesting note here is we have actually put a camera on that Raspberry Pi. You can see here the Raspberry Pi, and here we have a breadboard where we have, that enables us to make connections to an I2C sensor and a GPIO pin that is used for driving a LED. So this is actually a PC in another office next to me here, and this is a VCL application that is showing the view from a camera connected to that PC, and that is actually an FNC WX camera component that shows the camera within this VCL application. Let's now switch to our Raspberry Pi device, and this one I can access over VNC with based on the IP address. And so here you can see the Raspberry Pi OS on our Raspberry Pi. So what I'm going to do now is doing the Xcopy deployment of the generated application. And I will do this over a network drive that my Raspberry Pi can also connect to. So I have here in my folder Miletus, and I create a new folder here on this network drive. Okay, I select new folder, and let's call it a webinar. Like this. Okay, and we copy the generated Miletus application to this folder on the network drive. And here on our Raspberry Pi OS, we can also access that network drive. So it's under Bruno. And there we should have also the folder Miletus. Maybe it's faster if I type it. I guess that I might need to refresh that folder. I'm not sure why it is not yet seeing the subfolder that I created. Okay, it should be there, but I guess it's a matter of refreshing. I'm not sure where I can. Let's try the familiar F5 if I can. Okay, F5 works, refreshed. So here is the application, and so what I will do is create a folder here. We call this folder webinar, and now I will just copy these two files and paste them here so that Xcopy deployment is done, and then I can execute the application from here. And as you can see, this is exactly the application that we just built with Delphi, and it works as we expected. So that shows you how you can do the Xcopy deployment. All right, let's go a step further and have a look at how we can access local files on the Raspberry Pi directly from a Miletus application. And we have prepared some demos for that to make it fast. And so the first demo created is a kind of notepad application, and I will show you here. This is the notepad application, and as you can see, we have here a Miletus main menu component. We have a Miletus open dialog component and Miletus save dialog component. So the main menu, that's obvious. That's the component that gives us this little menu to open a text file or to save a text file. And we have an open and a save dialog. These are the dialogs that will run on the Raspberry Pi OS to pick a file. And basically from these dialogs, or from the menu better, we can perform the execute on the open dialog. Notice here that this open dialog execute method has an anonymous method handler. The reason for that is that it is an asynchronous process. So you will get the result asynchronously, the file that you picked from the open dialog. So this is what happens when the file was picked. It calls this anonymous method with the file name that was selected. And from this, or with this file name, we use the tMiletus stringlist class, which is a class that allows us to directly access or load a file from the local file system from the Raspberry Pi. So here you can see the string list load from file async. So also the file loading is an asynchronous method with an anonymous method handler that returns the text when the file was successfully read, and we assign this to the content of the memo. And a little bit similar we have for saving the file. So we execute the save dialog. Also here an anonymous method called when the file name was selected, and here we can perform the save to local text file through the tMiletus stringlist class. And so let's have a look at how this behaves on the Raspberry Pi. So I go to the Notepad demo. This was deployed before, just to save time. This is our application. So here I can open a file, and as you can see, this open dialog is the Raspberry Pi OS open dialog, and I can pick a file, and this file is opened. We added some Chinese characters just to verify that also Unicode text is properly handled, which it is. When I now change this content, hello world, from the Miletus Raspberry Pi OS app, and I form save as, and let's give this a name, hello world.txt, and we save this. Okay, if we go and have a look, you can see that this file was now generated. So if I directly open it from the Raspberry Pi, you can see that what we wrote to the local file system was also successfully saved. Okay, let's close this application. I'm not sure what happened there, but it is closed. And let's move on to our next project, which is a project that introduces some hardware. And that hardware is a LED display strip that is connected to the Raspberry Pi. So let's open, actually it's, I believe it's this project that we will open first. No, that's the last project. Let's first open the project that drives the Letsstrip, which is this one. And so what do we have here? We have an edit control and a button control, and we will write some text to a Letsstrip. But maybe first some background on the Letsstrip. This is actually the Letsstrip that is connected to the Raspberry Pi. It's connected via a UART. This is here the link where you can find the information about this hardware. And actually, I should be able to share that link in the chat, so you can directly also open it from there. Let me share it here with you. This is the Letsstrip that we are going to use in this application. To perform the communication with the Letsstrip, this is done via a serial port. And actually, the documentation from the vendor of this Letsstrip was very basic, meaning none. The only thing that was available was some C code that could be directly used on an Arduino. So what we did was actually reverse engineer the C code used for driving the display from an Arduino. We translated this to Pascal code, and this is what you will see here. Here we create the buffer of bytes that is needed to be sent over the UART to the Letsstrip, and that will turn on meaningful text on the Letsstrip. So basically, it's an array of bytes with some header. This is the header that we built here. This is the bytes that are generated for text that we want to put on the Letsstrip. And then at the very end of this buffer, there is a kind of end of buffer marker that gets calculated and is also sent. So this is the function that gets the text buffer. And here, when I click the button, you can see that, okay, we first get the text, and then we turn the text into the required buffer to send to the display strip. And then we use the Miletus Raspberry UART component to write that buffer to the serial port. And we await, we perform an await, because this write buffer call is also an asynchronous call. So with the await, we can write our code in a sequential way, but still deal with asynchronous methods. Here we have a look at, it's a real-time look at our Raspberry Pi. And you can see that this text is at this moment on the display strip. So let's now move to the Raspberry Pi and go to the Let demo and start this Let demo. And here you can see the text that we have prepared. If I select Write to Display, I expect that my display will be updated. And as you can see here, on the camera view on our Raspberry Pi, it updated. Let's do some more text so that you live at webinar, write to display. And here, let's have a look at the camera. You can see that this text is too long, then it scrolls. That's something automatic, an automatic behavior from that Letsstrip. But you can see that the text that we wrote to the Letsstrip is actually here live during this webinar updated. And so this small demo demonstrates how you can use the UART, and from that UART control and Letsstrip. Let me have a look, because I see two questions here. Well, maybe can I suggest to put the questions in the question tab? Then I will try to handle them this way. Okay, let's move now to the last demo that is somewhat more involved. And I open this demo here. And let's have a look at all the things that are happening in this demo. I first open the main form. And as you can see, we have here in this demo also some FNC components. FNC, as many of you, I guess, meanwhile are aware, is a type of components that is universal. You can use these components in VCL applications, in FireMonkey applications, in Lazarus LCL applications, but also in WebCore applications. And as you can use them in WebCore applications, it means you can also use these FNC components in Miletus applications. And that's what we are going to do today. We have the FNC gauge here, FNC chart, and here we have a toggle button. This is a WebCore toggle button. So what this demo will do is read from a sensor. It will read the air pressure, and it will read the room temperature. And here with this toggle switch, we will be able to use a GPIO pin to turn a LED on and off. First of all, some background about the sensor that we are using, which is a sensor for air pressure and temperature. It's from the company Bosch. We have no connections whatsoever with Bosch, so we are not sponsored by Bosch. It's just a component that we used, and that's all. And this is actually the link to the documentation for this sensor. I will also share it with you in the chat. So if you have an interest, you can also directly download it from there. And so this is what is described in the datasheet of the Bosch sensor. This is the operations that need to be performed to make a usable readout of the air pressure and the temperature. So a lot of values need to be read out, and calculations need to be performed to calculate the actual air pressure and temperature from the values that are read. So these are all registers to be read out from the Bosch sensor, which is an I2C device. So you will read it over I2C, and then it goes on. This is the whole set of calculations that need to be performed to, in this case, retrieve the temperature and the air pressure value. This is what we did in the Pascal code. And if we have a look at that Pascal code, here you can see the readout. This is actually the first part that matches here, reading out these calibration values. So that's the translation into the Pascal code. So as you can see, here we read out over I2C all these registers from the BPM 180 sensor device. And then we basically perform a loop where we will continuously read out the further registers from the I2C device to actually then perform the calculation. As you can see here, this is the calculation that determines the temperature returned by the sensor. And when we have retrieved that value, we set it to the FNC gauge. So the gauge will indicate our temperature. And the next calculations are preparations to actually retrieve the air pressure. And so after we did all the calculations needed and prescribed by Bosch for this particular sensor, what we do is add that value to our chart. So here you can see we have the chart. We retrieve the series where we will want to add that point. We add the value to that point, and that will update the chart actually. And finally, what we do is, if we have a different air pressure and a different temperature, then we also want to update the display strip. And so here we will send a text that we create that contains the pressure and also here the temperature. We will send this text generated via the UART to our display strip, and we wait a half a second here in this case before reading it again. So basically in a loop we are getting the sensor values and update the FNC gauge, the FNC chart, and also our display strip. In addition, we have that toggle switch on our form, so this one. And so if we inspect and have a look at the code for that toggle switch, basically we send the values 0 and 1, and we perform a GPIO write here in this case on GPIO pin 26, and this will drive the LED and make it blink or not. There's one more interesting tidbit here in this application, which is the initialization. So here you can see that we initialize our I2C component, and we set it to the address of our sensor, and we open it. We also open the UART, and we initialize the GPIO. So a GPIO pin on a Raspberry Pi can be configured to function as both input and output. As we will drive a LED here, we will want to make that pin 26 a writable pin. So this is where it happens. this is where we configure the pin to be a writable pin. So if we compile that application, what we already did for you, and run it from the Raspberry Pi, this is the result that we have. So here you can see the chart is being filled with the air pressure, which is around 1030 millibar. And you can see that the temperature readout by our temperature sensor at this moment is like 22.6 degrees. Let's switch over to our camera, where you can meanwhile already see that it updated the display strip with the read out air pressure and temperature. And you can see here in the middle of the screen, you can see that blue LED that is on. So if I now switch to my Raspberry Pi and turn off the LED like this, and we switch back to the camera, you can see that the LED is off. So that means that we can successfully manipulate the GPIO pins on the Raspberry Pi. So the LED is back on right now. And with this, we have shown what you can do actually with Miletus for Raspberry Pi. Not only create applications running on the Raspberry Pi OS with user interfaces, but also directly manipulate the hardware that you connect whatever hardware over I2C and over SPI or via the UART. You can use that on the Raspberry Pi. So let's turn back to the presentation. And as a conclusion, I have prepared one more poll. And in this poll that I can show you right now, that should appear on your screen. In this poll, yes, we are interested to hear what kind of projects you're thinking of building with the Raspberry Pi. And also, of course, we are very curious to hear if you see additional functionality that you would want us to expose in Miletus for Raspberry Pi. So I give you some time to fill in these polls, and when you're ready, then we can have together a look at the results. So some more time to fill in these text questions. So, okay, I start the countdown. 20 seconds to complete your answers. And it's counting down. Finish the answers, and then we can have a look at your answers and go over them. Okay, that happened. 5 answered. What kind of projects do you think building with the Raspberry Pi? I need to save the answers here. Okay, and save the other answers for the questions. What extra functionality would you want to see in the future? Okay, so these were saved, and we can now look together at the answers. So this is the set of answers for the first question. So no serious projects in mind, connecting to instruments to receive data, label printer control over the serial port, use the Raspberry Pi to drive an HDMI display for an embedded system, and a temperature and air pressure monitor, cut port monitor, etc. So this is the kind of things that you apparently have in mind. And then here, suggestions for future extensions to Raspberry Pi support in Miletus, and that is here I see the SPI slave functionality, so we'll have a look at that, as well as looking what is eventually possible with the Raspberry Pi Zero. Okay, and now I have a look at the chat box. How much is Miletus? So I guess that this refers to the price of Miletus. Well, Miletus is actually integrated in TMS Web Core. So if you have Web Core, you have Miletus anyway. And so the Web Core price, this one starts at I believe 395 euros. So you not only have all the Web Core capabilities, but you also have all the Miletus capabilities all packaged in one product. That is for the reason that the running application within the Miletus for Raspberry Pi app is of course a Web Core application, and you create it with all the Web Core components and technology libraries, etc., that are available for Web Core. I see that someone suggests that we should write or create a coffee machine driven by an Miletus for Raspberry Pi app. That would be extremely cool and a very nice and cool project, of course. Another question that I see is Miletus for Raspberry Pi support coming in TMS Web Core for Visual Studio Code? The answer to that question is yes. At this moment, there is already Miletus support in TMS Web Core for Visual Studio Code, but at this moment, this is for the Windows, Linux, and Mac target. And we will add the Miletus for Raspberry Pi target in version 1.9, which our team is working on hard. So that means that you will also be able to create Miletus for Raspberry Pi apps from Visual Studio Code, and of course from Visual Studio Code running on either a Windows machine, a Mac, or a Linux machine. That is your choice. Let me have a look at more questions that I see here in the chat box. What about door entry products with voice over IP using SIP? Yes, that is also a very nice suggestion. And it depends on, first of all, the hardware that you will connect to the Raspberry Pi and the interfaces, the protocols that you use to use this voice over IP, for example. It is something to be explored, and let's have a look. Our team would need to have a look, or you can have a look, via which technology you can access these devices. But I'm thinking in the direction, if voice over IP, that there are libraries, web-based libraries to achieve that functionality, and that means that you could that would probably be the fastest way to integrate that into a Miletus application, Miletus in general, but also Miletus for Raspberry Pi in specific. And here I see another question: how to program effectively in Delphi for ASA level CS. Want to include support for Raspberry Pi from Delphi, so Miletus support is highly relevant. I'm not sure I understand the full meaning of that question. So I'm not sure how to interpret that question. If this is in the direction of more help to create Delphi applications that target Miletus, well, in the first place, note that the application that you create in Miletus is a web core application. So you use exactly the same web core techniques. And there are several webinars. There's a training course from landgraph.dev regarding web core, but there is also a web core book. There is the web core manual. So I think the web core book, you can find it at Amazon. So if you search there for TMS Web Core, you will find the web core book there. If you navigate, maybe I will enter that URL, https landgraph.dev. That is where you will find the training course. The sample projects, can we share them? Yes, we can share them. There's no problem in sharing them. We will create a download link that we will include with the replay of the webinar that we will send out. One note here is, of course, that to run these sample projects, you need to have the same hardware setup. I mean, the same display strip and sensor connected on the same ports on your Raspberry Pi to run them out of the box. But I guess other than that, it's most likely also a useful learning experience to check that source code. I see another comment that the answer from Kevin in the poll was not retrieved after our webinar. I will check again in the logs to see if maybe an answer was not yet in the log when I retrieved it, that it just was added afterwards. So I'll check that out, Kevin. And I'm very sorry, but I did not understand your question about how to program effectively in Delphi. So if you have more specifics about that question so that I can properly answer it, please let me know. I have TMS Web Core, not Visual Studio Code. Does Miletus run in this? Well, yes, if you have the latest version of TMS Web Core. 1.8.5 is the latest official release. This has Miletus built in, and so this enables you to create Miletus applications for Windows, Mac, and Linux. The Raspberry Pi support is what is coming for WebCore 1.9. And if you have an active license for WebCore, you should find the 1.9 beta. And it is actually in this 1.9 beta that the Miletus for Raspberry Pi support is integrated in. And so you can use this beta to do what we did today. And our team is working hard to release that beta, to make it an official release as soon as possible, as soon as we have the last technical hurdles overwon. Other question I see from Benno: does the UART over USB work? That is a very interesting question. And my answer to that is we would actually want to test it ourselves before confirming. So I would say to be followed up, we will connect some USB hardware that functions as a serial port to the USB on the Raspberry Pi and verify that the UART code is working over that. So to be followed up. And then another question: does the free Pascal compiler come with Miletus? It does not come with Miletus. You actually don't need it to generate the Miletus Raspberry Pi application. It is all performed from the Delphi IDE, so there are no extras, no additional things to install. Everything, if you install TMS Web Core 1.9, everything will work out of the box. There are no additional things to install. I see here that there is an audio question. Let me see if I manage to take this live question. Mr. Ghazali, if you press your microphone button, normally I should be able to hear you. Hello? No? Normally I enabled the microphone for you, Mr. Ghazali, and that means that you should be able to click on the microphone to enable it on your side, and then I should hear it, but I hear nothing. So I suspect that you have not either not connected your microphone. I see. Sorry, it's an error. So okay, no problem about that. Will you develop a controller area network library? Can I write that down, Robert? Not yet in the works or on the plan, but to be discussed with the team. And it, as always, with the developments, what we do, everything is in your hands. Let us know what you have an interest in, what you want to see made easier, all these kind of things. And our team is listening, and we try to bring the tools that you need in an as easy as possible way. So if there are no more questions at this moment, I have one final poll, and that is the poll to measure how much you liked our webinar and how well I performed or not. So to monitor the quality, 3 more ratings to give. How do you rate the session content? How do you rate my performance here for bringing this webinar? And how do you rate the overall experience here in the TMS Web Academy, which, by the way, is a development that was entirely done in TMS Web Core. So as you can see, we eat our own dog food. Web Academy is created with TMS Web Core and is giving us the capability to organize things like this since February, because we launched the TMS Web Academy on February the 15th this year. So your evaluation of this webinar is counting down right now, and we just wait a few seconds for everyone to finish the result, and then we can have together a look at the result. I will share it as soon as it's done. And we have a very nice rating, for which, of course, I thank you very much. I share right now with you how do you rate the session content. Everyone apparently was very pleased with the content. Thank you very much for that. The speaker was equally well rated by 26 people in this case, and the overall experience of the Web Academy also scored very good. So I can't thank you enough for being here, for your interest, and for allocating your precious time to follow this webinar here. So, and an open invitation, as always, if you have suggestions for Miletus in general, Miletus Raspberry Pi, or suggestions for future webinars, content that you want to see covered more in depth, you know where to find us, email or the support center. You can let us know, be in touch, communicate. Our team is always listening. And for the remainder of the day, I wish everyone a great remainder of the day and week, and see you soon here on a follow-up webinar. Thank you very much all, and till soon. Bye-bye.